Good morning, class. So in this live lesson recording today, we're going to be going over the Unit 7 Lesson 4 notes, which is about the surface area of cones. So just as a reminder, I know we just had a long weekend for a lot of us. So just as a reminder, we're going over various shapes, and we're looking at surface area and volume in this unit. So in Lesson 4, surface area of cones. In Lesson 5, we're going to go over the volume of cylinders, and then in Lesson 6, the volume of cones. So right now, we're looking at the surface area, which means if you were to unfold a cone, how much area does it cover? So that's what we're looking at here. So a couple things to note, or really just one thing to note. So surface area is equal to pi r squared plus pi rl. So pi r squared is the circle. Pi rl represents this area up here. So remember, area is two-dimensional, whereas volume is three-dimensional. So if I was asking you how much space is inside of that cone, that would be the volume. Surface area is just how much surface is covered by the two pieces here, if we were to unfold it. So again, this is the circle, and this is the actual cone part of it. And then the second thing to mention here is that here they call this S for slant height. In the formula, it's L, so really we could probably just replace that with an L. So it's not too confusing, or we could replace this with an S for slant height. But we're going to go with L because that's like the standard is L. Or sorry, yeah, L for the slant height. All right, so with that being said, pretty simple formula. So all we gotta do is follow that formula. So it says, what is the surface area in square centimeters of a cone with a diameter of 12 feet? And a slant height of, by the way, this should be square feet. I'm not really sure why it says centimeters, because we are not going to try to convert this. That's really weird. Okay, so our formula is pi r squared plus pi rl. So surface area is equal to pi r squared plus pi r l. Okay, so remember r represents the radius, but in this case it gives us the diameter. Well, remember that radius is half the diameter, so we only want half of that. And for pi, we're just going to use 3.14. And what I'm going to do is, since we're going to use the same formula over and over in this, when I go to Desmos, I'll just replace the pieces that we need to change. So in this case, 3.14 times 6 squared plus, so the radius is 6 because 6 is half of 12, and then plus pi, so 3.14 times the radius, which is again 6, and then the slant height is 14. So I'm putting it in parentheses. When I put it into Desmos, I'll just put multiplication sign. All right, I'm going to move my picture here, my video. So 3.14 times 6 squared. Okay, so that's the first part. Plus 3.14 times 6 times 14. So R, so this is the area of the, this piece is the area of the circle. This piece is the area of the cone part of it. Okay, and we get 376.8. So it'd be 376.8 square feet, or feet squared. And that is it. And again, Desmos does the order of operations correctly for us. We don't have to worry about the order of operations here, because Desmos knows to do this first, and then do this, and then add those two together. All right, this one, same thing. So we could really just go back into Desmos without having to write all this out. But remember, here's the formula, pi r squared. So pi is, again, 3.14 times r, which, again, this time it's 6 again, squared, plus, and then it's 3.14. So pi times the radius times the slant height. All right, so really, actually, this one, the only thing we have to change is the 14 to an 11, because the radius was the exact same as the last one. And we get 320.8 320.28. And in this case, we don't know what it is. So we're just going to call it 320.28 units squared. We don't know what units they are. Or square units. Doesn't matter. Either way. All right, number 3. All right, we actually have a different one here. But again, it gives us the two pieces we need. It gives us the radius and the slant height. So just as a reminder, the formula is 3.14 times the radius squared, so 10 squared, plus, and then 3.14 times the slant height, times the radius, which is 10, times the slant height, which is 15. All right, so we'll go into decimals, and we're just going to change our 6's to 10's because the radius is 10 this time. And this time the slant height was 15. So that's the nice thing about decimals is I can just come back in here and edit the formula because it's the same formula every time. We just need to change the numbers. Oh, oops, I forgot to look at the answer. 785 exactly. So this is 785, and in this case it's inches squared. All right. Now this one's a little bit tricky because now it's giving us the diameter instead of the radius, so we'll just have to cut that in half. Okay, so our formula is again pi times the radius. So half of 25 is 12.5. We will square that, plus 3.14 times the radius, again that's 12.5, times 22, which is the slant height. Again, it's the same formula over and over again here. So we'll change the radius. Instead of 10, it'll be 12.5. So we'll have to do that twice because radius is in the formula twice. And then the slant height for this one, I believe, was 22. I'll have to double check that to make sure. Yeah, it was 22 right here. All right, and our answer is 1,354 we'll just call it 1. We'll round it here at the 1. So 1,354.1. 354.1, and then this one's centimeters squared. Or square centimeters. Ooh, this one's a word problem. Okay, so this one says a designer's creating a modern art sculpture of an hourglass out of steel to be on display at the town library. The hourglass is made by 2 cones meeting at the top point. The designer wants to know how many square feet of steel is needed for the outside of the sculpture. If the slant height is 6 of each cone, and the diameter is 10 feet. Okay, so again, it's given us diameter. We want the radius, so half of that. Okay, and then what we're going to do is, since there's 2 cones at the end, we'll just find our answer for 1 cone and multiply that by 2. Okay, so that's 3.14 times the radius, which is half of 10, so 5 squared. I don't know why I keep putting that in. I'm going to erase that. The 2 should really kind of go in the parentheses here. Or the square should. Okay, plus, it doesn't really matter because we're just going to plug it into decimals anyways. All right, so 3.14 times 5 squared plus 3.14 times the radius, again, which is 5, and the height of the cone, slant height, is 6. All right, so again, I'm just going to go back into decimals. This time the radius is 5, so I'm just going to change it to 5 instead of 12.5. And then the slant height was, I hope I just remembered that right, 6? Yeah, 6. All right, so our answer is 172.7 for 1 cone. So what I'm going to do is I'm just going to come in here and do 172.7, and then I'm going to multiply that by 2. So 345.4 is our answer. Because again, there were 2 cones that made up that sculpture. Okay, so 345.4, and then this was feet squared, or square feet. All right, last but not least, a cone-shaped megaphone has a radius of 15 centimeters and a slight height of 20 centimeters. A megaphone has an open bottom. What is the lateral surface area of the megaphone in square centimeters? Okay, so this one, that's interesting. This one's only asking us for the lateral surface area. Okay, so I want to show you real quick in this formula. This piece again represents the circle, and it's saying basically we don't want this piece of it. We don't want the circle. We only want the cone part of it. So this is all we want. We only want pi RL for this one because the lateral area doesn't include the base, which is the circle at the bottom. And that's because if you think about a megaphone, like they have that big opening at the end. Okay, so we're only doing the pi RL part of this formula. All right, I have to go back and switch to the pen. Okay, so we're just doing pi times the radius, which is 15, times the slant height, which is 20, for this particular problem. All right, we're going to get rid of that. So 3.14 times, I already forgot the numbers, 15 and 20. Times 15 times 20. So that's just the lateral height there, or lateral surface area. So that's 942. And in this case, it is centimeters squared. And that is it for Unit 7, Lesson 4, all about the surface area of cones. If you guys have any questions, feel free to reach out. But otherwise, have a fantastic rest of your day. And we'll be going over Lesson 5 and 6 a little bit later on today. Have a great rest of your day.